This is part 2 of section 11.6. So, if it is impossible for two events to occur at the same time, the events are said to be mutually exclusive. This correlates to the idea of disjoint sets from section 2.3 as well as self-contradictory statements in section 3.4. So, when I'm talking about mutually exclusive sets, when we were talking about sets, this would be the case where there's something over here and something over here, but nothing in there. Okay. One way you may remember seeing this when we were talking about sets is they would draw two circles that did not touch at all. Okay. We were sometimes asked to find the number of objects, number of elements in any given set. We're still going to be using kind of this idea as we're going along here. Okay. So thinking in terms of sets, if you had mutually exclusive events, then A intersected with B, which is where they're overlapping, was the null set, meaning that there was nothing inside of it. So that's what I just talked about with the pictures. So if we want to find out OR probability with mutually exclusive events, so if A and B can never happen at the same time, then the formula we have is the probability of A or B is equal to the probability of A plus the probability of B. Okay. Suppose you randomly draw one card from a standard 52 card deck. Find the probability of selecting a red 7 or a black 8. Okay. Well, you can never have any kind of overlap between a red 7 and a black 8. So those are mutually exclusive events. So the probability, I need to figure the probability of each of these. So the probability of a red 7. Well, there are 2 red 7s out of 52. Okay. The probability, I can reduce this in a second. The probability of a black 8 is going to be the same, right? Because there are 2 black 8s and there are 52 cards. So both of these reduce down to 1 over 26. So the probability of red 7 or black 8 would equal 1 over 26 plus 1 over 26, which is 2 over 26, which is 1 over 13 when you reduce it. Okay, so let's do the same thing here, except we're getting more specific. We don't just want a red 7, we want the 7 of hearts. We don't just want a black 8, we specifically want the 8 of spades. Well, the probabilities of these are pretty easy because there's really only one way we can draw the 7 of hearts. There's only one way we can draw the 8 of spades. So the probability of 7 of hearts or 8 of spades would be the probability that we draw the 7 of hearts, and there's one way of doing that out of 52, plus the probability of drawing the 8 of spades, and there's one way to do that out of 52 possible ways to draw a card. So this is 2 over 52, which is 1 over 26. Okay, so let's say that a political discussion group consists of 30 Republicans, 25 Democrats, 8 independents, and 4 members of the Green Party. If one person is randomly selected from the group, find the probability of choosing a member of the Green Party or an independent. Now, these are mutually exclusive events because people don't belong to more than one party. So there's no possibility if I choose somebody from the Green Party, I also accidentally choose an independent. That's not going to happen. The first thing I have to do is to figure out how many people there are that I'm choosing from. So there are 30 Republicans and 25 Democrats and 8 independents and 4 Green Party members. So that adds up to 67. Okay. So the probability that we choose somebody from the Green Party, there are, how many? 4 members of the Green Party. So 4 out of the 67. So that's the probability of choosing someone from the Green Party. The probability of choosing an independent would be, there are 8 independents, so 8 out of the 67. So the probability that we choose somebody from the Green Party or an independent would be 4 over 67 plus 8 over 67, which gives you 12 over 67, and that does not reduce at all.